NSTA welcomes you to the Elementary Extravaganza at Engage Spring 21. Today's presentations are brought to us by NSTA's Committee on Preschool and Elementary Science Teaching. Welcome to the Elementary Extravaganza.
Hello everyone and welcome to the Elementary Extravaganza. My name is Judy Boyle and I am the K-8 teacher at Divide School in Divide, Montana. And welcome to my presentation on using models to help students make sense of the moon and its phases. The DCI that we will be meeting with this activity or series of activities is Earth and Space Science 1, ESS 1-1, in which students are asked to make observations of the sun, moon, and stars and describe the patterns that they see, which is the cross-cutting concept that we will be meeting. There are two essential questions that we'll be covering. Why does the moon change its shape? And how does the moon change its shape? It's important to ask students these questions before you begin to see what misconceptions there are in your classroom. I begin the activity with a YouTube video from NASA showing the moon as it travels through its phases. There is no voice during this period, but it just allows the students to observe what happens to the moon as it goes through its 28 days, and this will happen in 28 seconds. I allow the students to view the full video 2 times. The third time I pause the video at the full moon phase, trace the moon, cover the projector lens, and allow the students to see my model. Students will need to divide their paper into 8 sections and use their lids to draw 8 circles. The first circle should be labeled the full moon. You will need to continue this as the moon moves through the 8 phases. Another idea for this activity is to use black construction paper and white or yellow chalk to color the lighted side of the moon. Just don't forget to have your students label the different phases as they draw them. When the students finish, lead them into a discussion on what patterns they see from their model. Allow them to share their drawing with each other and make sure they place them in their science notebooks. They will use them when doing the next 3-dimensional modeling activity. The next activity is designed to guide the students with a trade book written by Emily Morgan called Next Time You See the Moon. If you don't own the book, you can visit her Read Aloud YouTube video. Follow this with her 3-dimensional modeling activity, which she demonstrates in the second YouTube video listed. In my third slide, I posed 2 questions. Why does the moon change its shape? And how does the moon change its shape? These 2 questions are worded incorrectly, but are heard frequently in everyday discussion. Let your students engage in discourse to answer these questions and strengthen their sense-making. Then, let them try Emily's demonstration. After the students have experienced the demonstration, ask them to share what they have learned, keeping an eye on misconceptions. I have circled 2 comments on the board. The first is circled for clarification. The second is a misconception. The phases of the moon are not made because of a shadow. A lunar eclipse is caused by Earth's shadow, though. This prompted more questions. Now that the students have been exposed to the moon and its phases, they were eager to share their knowledge with their parents. It was just the right moment. A full moon appeared, and I received text and email photos of families making their own observations. A teacher knows that when students bring their learning home to share, their teaching has made an impact. You will love collecting a list of your students' aha moments when they discover something that they never knew existed. Number 6 in my list is my favorite. When a first grade girl discovers that a model depicting the tides is totally wrong and a misconception. next day, the students came in with questions and were eager to ask, why can we see the moon during the day? Why can't we see stars during the day? Why does the moon have craters? What does a moon rock look like? What causes a lunar eclipse? What causes a solar eclipse? For social studies integration, you can include many Native American or First People stories. You can also include the West African Anansi's stories and celebrate the Chinese Moon Festival by reading Thanking the Moon by Grace Lin. Thank you for visiting my presentation. I hope you enjoy Elementary Extravaganza and NSTA's Engage 2021. If you have any questions, please don't hesitate to email me at sagemountaintrail@gmail.com. Thank you.
Hi, I'm Ashley Townsend. I teach STEM to kindergarten through 5th graders just outside of Baton Rouge, Louisiana. I'd like to tell you a little bit about stop motion science. We use many strategies to help students make sense of our world. Sense-making discussions, science journals, and modeling are just a few examples of ways we engage our students in the science and engineering practices. How can we use technology resources to enhance these practices and help prepare students for our digital world? Stop motion is a way to make animated video. You take multiple pictures of objects, moving them a tiny bit between each picture. When you play the pictures rapidly back to back, it looks like the objects are moving on their own. Most of your students will know stop motion animation when they see it, but they might not know what it's called or how it's made. My students are amazed to learn that they can make their own Lego movies, just like their favorite YouTubers. That's how I introduced stop motion to 2nd graders, by having students make simple Lego videos. I start more simply with kindergartners and 1st graders. We first learn to make it look like one block is moving all by itself. We then practice working with multiple moving parts. Finally, we learn to include audio.
Loud. 3 plus 2 equals 5.
With the little ones, I find it especially helpful to have them work with a partner. They take turns working as mover or clicker, so that one student moves the subject while the other captures the photo. This makes it a little easier to make sure hands are out of the way, which tends to be the hardest thing to remember. Once students are proficient with basic skills, I ask them, how can we use stop motion to help us understand science? We then incorporate it for different topics throughout the year. An easy one is vocabulary review for a digital word wall. Can you guess the word?
Water is all around an island. Precipitation.
These 2nd graders were just drawing one detail at a time and taking a picture with each addition. Sometimes we use these short videos to record our understanding. They make great discussion starters as we look for ways to improve our models. This one is kind of like an outline.
The flower sprouts and grows.
We realized that we needed to discuss that a plant grows for a bit before making a flower. Thinking about processes in terms of their steps helps us better understand how the steps work together.
Waves splash and make the rocks fall.
I also find that acting out concepts and terms in this way improves written explanations. They think of the words more easily because they have already pictured them in their heads. We use the free Stop Motion Animator Chrome app on our Chromebooks, but there are lots of options. A colleague of mine loves Cloud Stop Motion, and Stop Motion Studio is also popular. You can even use presentation software with animations to create a stop motion effect. That actually worked well to record the results of daily investigations in our 3rd grade plant unit last year. It helps to have a viewing space to see where your subject will be when you press the capture button to take your next photo. Remember that tech is a tool, not a goal. This is a technology tool that has been easy for my students to pick up and allows them to use technology without diminishing their thinking about content. For bigger projects, they may help to brainstorm and get feedback before jumping into production. Asking how can we improve our models initiates discussions that reveal misconceptions, offer opportunities to argue from evidence, and call attention to details. Kids are scientists too, and their work helps themselves and others grow. The goal is not to create identical products, but to create animated representations that really mean something. Thank you for watching. Feel free to reach out with questions or ideas. Have a great day.
Welcome to Sea Turtle Explorations, the beginning. I'm Ann Lowry and I teach pre-K in Reno, Nevada. In this video, I show how my students built upon their knowledge of sea turtles through using science and engineering principles. This video covers the first part of the project. During the presentation, I can answer questions about the second part, planned for April of 2021. The project started after my students saw the phenomenon of cold-stunned sea turtles washing ashore on the Gulf Coast earlier this winter. They empathized and also wondered why. They have seen sea turtles in Monterey Bay, and as one student said, "That water's really cold." They decided to learn about sea turtles. We started as we usually do, with transcribing ideas. We're still working on the difference between statements and questions. This way we can collect everyone's thoughts. Our inquiries are never linear. We often weave back and forth as the children add new knowledge to old and discover new questions. Our question list has just reached 4 pages. They decided to start with baby turtles. Using ping pong balls as well as student-made eggs, they created sea turtle nests in sand. Questions came up. Why aren't the eggs sand-colored to camouflage them? What if someone stepped on the nest? What happens if the sand gets too hot? Will the eggs cook? And then we had discussions about how to answer and test ideas. We decided we could use books, websites, and our own experiences, but that led to other discussions. What made a reliable source? We already know that the age of the book is important because people do new research. But what about books that say something different than all of our other books? That just means more research. The children worried about protecting the eggs from predators such as raccoons, snakes, seagulls, and people. So they built structures to protect the eggs. However, these structures couldn't heat the sand and had to leave enough space for hatchlings to easily escape. After trying this, the children decided that finding nests and building structures over each one would be too time-consuming. Protecting eggs from predators made the children wonder about the role sea turtles play in the food web. After reading several books, the children realized that without sea turtles, there would be so many more jellyfish, who would then eat fish and crustacean larvae, which means lots of other sea creatures would disappear in addition to the sea turtles. Sea turtles are key. The children went back to the hatchlings following light sources, which led to many other questions about sea turtle vision. How well do sea turtles see? Do they see the same colors as humans? They reasoned that because the ocean looks blue and green, sea turtles might see blues and greens better than other colors. They tested this with a sea turtle eye scope using filters. The children thought that the blue filter showed the colors well, but the red was darkened. They added a new question to the list. Is this why so many fish and corals are brightly colored? They decided to create a chart comparing sea turtles and humans. The chart included environment and anatomy, but the children are most interested in how sea turtles use their senses. Remembering that voices sound different underwater, the children tested rubber band instruments and tuning forks, both air and underwater. They consistently heard higher sounds in the air than underwater. They think sea turtles don't hear high sounds as well as we do. They also talked about splashes from plucking rubber bands underwater and wondered if sea turtles feel sound waves. The interest in sea turtles made them wonder what tools would be best to investigate the insides of a sea turtle. X-ray machines, not uncommon to many, were the first proposed, but several students remembered that X-rays show bones best. What about sonar? Would it show information about sea turtles? What about sea turtle nests? Back to sea turtle eggs and the pollution children found on beaches. They wondered about the effects of the pollution on eggs. What would happen if an egg were wrapped in plastic? What about an egg submerged in a soft drink as if poured from a cup? That they have watched, fascinated, as the eggshell dissolved daily. They're convinced the soft drink destroyed the egg. Right now, they're wondering how they could convince people not to pour out their drinks on beaches. As one child said, it might hurt sea turtle eggs. It might hurt another plant or animal too. They have also been captivated by a plastics pollution bottle another class created back in 2017. To think that the plastics were put in that bottle about the time they were born and still hasn't changed, that amazes them. Though we have yet to answer our initial question about how cold is too cold for sea turtles, we have answered others and asked even more. After break, the children want to find out more about the tools used to investigate sea turtles and have invited several local scientists to talk with them over Zoom. Thank you for joining my class in the first part of their sea turtle exploration. Through this, the students have had daily authentic work in each one of the science and engineering practices, as well as introductions to several cross-cutting concepts. They continue developing their learning dispositions and
Welcome to my presentation on Green Architects, The Wall is Alive. My name is Annette Venegas, and I am the Science and STEM Instructional Specialist for Kent School District in Kent, Washington. This unit engages students with many of the Grade 2 science and engineering standards. The lessons connect students with real-world applications and entrepreneurs in the field. It integrates science, engineering, math, and literacy, and engages students with 21st century skills. I had shown my students pictures of the straw bale garden and my hanging vertical planters. They started asking questions about why I would grow plants like that, instead of in the ground like most people. I caught myself from answering the question and instead asked them, why do you think I would do that? That started all the questions. I looked around for an engineering unit that incorporated lessons on vertical gardens, and I found one called Green Architects. The unit used an anchoring question: how can we develop buildings and communities that work with and preserve the environment? Incorporates many of the science standards and ends in a summative challenge. I introduced the summative challenge at the beginning of the lesson cycle to provide the why that students were working through all of the other sense-making investigations. In the summative challenge, students will be designing and constructing a green home that is suitable for the area in which we live. To build their house, they must understand many science concepts. To build a foundation on green architecture, students listened to the story, Earth-Friendly Buildings, Bridges, and More, the Eco-Journal of Corey LaPont. Then, for a history tie-in, we discussed the history of green architecture, and they recorded information that interested them on their own copy of the timeline. The first activity was What's Available? Students gathered information from various sources on the natural resources available in our area. This included determining where water is found on Earth and in our area, as well as learning what building materials and plants are available locally. In the next activity, students explored the types of natural disasters and hazards of our area, with the goal of understanding the design criteria for their green building. They had to gather information about Earth processes that occur quickly, such as earthquakes and forest fires, or slowly, like wind and water erosion. This led to Which is Better? In this comparison activity, students compared two architectural or building strategies designed to slow or prevent wind or water from changing the shape of the land and decide, with a justification, which one they thought was better. We took a break from investigations and got some reading in. Students read about sustainable design and then were introduced to Callie, Carrie, and June, three entrepreneurs who work in the field of architecture and sustainable energy. Now we're at my favorite part of the unit. The wall is alive. This is the part that originally captivated the students. Now it's their turn to design a living wall. Students started by planting in one felt pocket container, following instructions in their journal. As the plants in the pockets grew, students researched how the plants in their living walls would interact with the animals in our area, specifically highlighting how plants and insects depend on each other for survival through nourishment, plants supporting insects or animals, and pollination, insects and animals supporting a plant. Students worked in a group to decide what they wanted to plant in their living wall. All the groups did not agree on a doable plan, so we did not complete the planting of all the living walls. Some refinement is needed for the planning phase, possibly clearer criteria and constraints. The summative challenge was the final part of the unit. Students designed a model of a green home that was suitable for the area in which we live. The criteria stated that the house plan had to demonstrate an understanding of the natural resources, climate, and possible natural hazards. It also had to incorporate ideas from their planning pages. This ends my presentation on Green Architects, The Wall is Alive. If you have any comments or questions, please contact me at amv0528@gmail.com. Thank you.
Hi, this is Wendy Lawrence, and welcome to my presentation on creating science authors, helping your students make books about the moon. The idea for this program came from a combination of Eleanor Duckworth's Having of Wonderful Ideas and Watching the Moon, and a PD I went to at the University of Utah's Book Arts program. When you combine them, you have students developing their own thinking and ideas about the moon in a book. I put together a design for the learning, and you can just stop the slide and read it. But the big thing is for the students to design the learning, the protocols, and how they're going to record the data, talk about it, make these changes. They are authoring what they see. So that's the biggest thing you're looking for, is students empowered. A unique way to do this is use back to school or friends and family night and have a telescope come to school. Empower the parents or friends of the students to be a part of the project. Make books in the hallway. Have them decide how they're going to tell stories and bring it back together as a group. It goes really, really well. To make your books, you can go to the University of Utah's website. It's the Book Art program, and make a simple center cut book. The link is here. Easiest way to start with your students. If you want to get a little more complex, you can add covers, you can color it in, you can paint. They could have multiple books over time. Or you can go to this next one, which has more complex folds. It depends on how old your students are. But take a look at the different folds that can go inside these books, and you will be absolutely fascinated with what they can create. Having the students decide on the protocols for observation is critical. It teaches them to be the observers, to look at what they're learning. How do they communicate it? What did they observe? What do they do? Is it data if you can't see the moon? Are there clouds? Are there not? What if you see it and I didn't? How much data should we record? This is really important. Let their vocabulary emerge. Don't give it to them ahead of time. See how they're going to describe it. And then don't forget, one of the most important things here is to pay attention to safety. This is at night. What's safe for kids, what's not. You guys need to figure that out as a group. Make your agreements and work it out as a class. This really is about telling the story of the moon and how you observe it. It might include cultural, might include things your family does, your community does, your school does, but you want to make sure the students are telling the story of the moon within their context. So it relates to their lives, as well as to the phases and things we learn on the science piece. All kinds of ways to collect data. This is one book that I put together with different dates and what the phases looked like, predicting where it would rise in the mountains near my house. And so we put this together to kind of give the whole story, and there were more in the folded in pages as well. Great thing to keep in mind is observe, document, share, and repeat. The students need to do this more than once. Scientists observe more than once. And NASA has some great stuff where you can follow lunar science, and the students can take a look. Websites are up here, and you can follow along with moon.nasa.gov. A few more NASA resources for moon information, for observations and posters and advertising this. And I did put a link to NASA Eclipse about the moon in case you want any more information. This has been a super fast tour of how to write books about observing the moon. I hope you have an idea to use with your students, and I wish you the best. Teach on!
Hello Hello and welcome to Teaching the Engineering Design Process in a Virtual and Hybrid Classroom. I'm Jennifer Williams, the Lower School Science Department Chair at Isidore Newman School in New Orleans, Louisiana. Prior to the pandemic, our department followed 5 guiding tenets that our students in grades 2 through 5 would learn the engineering design process through a project-based, literature-based, place-based learning function. Students in grades 2nd and 3rd would be introduced to the original engineering design process model developed by the Museum of Science in Boston, and they would participate in multiple design challenges. In 4th and 5th grade, our students would use the new engineering design process model, in which engineers share their designs and critique each other's designs. However, our whole world was upended on March 13th when our school closed due to the pandemic. We had 4 main issues when transferring our guiding tenets to the virtual learning platforms. Our students were located all over the world. We had students in other states and other countries because we had been on our Mardi Gras break. How could we transfer all 5 of our guiding tenets to a virtual or hybrid classroom? How would students be able to document their learning and see our lessons? We decided to use programs such as Google Classroom, Zoom, Padlet, and Seesaw. And then how would we go about crafting relationships between students? Realizing at the beginning of the school year that we would have students that were in class and remote and in hybrid situations, we developed a series of design challenges and units that would expose our students to the engineering design process and give them the opportunity to participate in STEM challenges no matter their location. One of those challenges was a 3rd and 4th grade unit called Protecting Our Riders. Every day, thousands of New Orleanians use our historic streetcars to get to and from work, school, and shopping. However, many of the streetcar stops offer no protection from the elements for our riders. Students were given the task of creating a prototype covering that would protect riders at our various streetcar stops. Following the engineering design process, students began by asking questions. Here are a few of the questions that were typed into our Google Classroom. How long is the streetcar line? What's the difference between the red ones and the green ones? How many people fit on a streetcar or at a stop? And one child even noticed that the streetcar stop by his house had no room for a bench or a cover. We then began the process of researching the streetcars. Using these different pieces of literature and the Regional Transit Authority's website, students began to learn about the 25 miles of rails that surround the greater New Orleans area. Then students were asked to imagine possible design structures that could be built at a streetcar stop of their choosing. These sketches were done in notebooks. You can see here are 2 of our remote learners showing their designs during a small group discussion. Once students had settled upon a design, they would be given their engineering bags. These engineering bags, one for each unit, were mailed to students' homes if they were remote or in a hybrid situation. Students in class were also given the same materials. Once they knew their limits and their constraints, students could then begin writing a plan for their prototype. And then we would begin to create. Here is Mia starting the creation of her streetcar stop in our classrooms. However, this was also done by our students who were learning remotely. In their notebooks, no matter if you were remote or in class, you were documenting challenges and possible changes in your science notebooks, and you would bring these challenges and possible changes to our small group discussions. Students at home and in class would meet in small groups where they would be able to have social interaction and discuss the challenges that they were facing as engineers. This allowed for socially distanced collaborations. Upon completing their prototypes, students would photograph and describe their structures on our Design Challenge Padlet wall. Here are 4 examples from that Padlet wall. Students could then rate or like each other's designs. In conclusion, while teaching the engineering design process remotely was a challenge for our teachers, we did find that it helped to build collaboration between our in-class and our remote learners. It allowed us to follow our guiding tenets, and it supported our students in their learning of the engineering design process and STEM at Isidore Newman School. Thank you for joining me today. If you would like to learn more about using the EDP in your virtual classroom, please feel free to email me. Enjoy the rest of Engage Spring 21. Thank you for attending today's elementary extravaganza. Please stay tuned for the question and answer session with today's presenters. And don't forget to fill out your session survey form. Thank you for attending Engage Spring 20.